Brawley. Thank you very much for joining us here on AU Manufacturing Conversations, and thank you for having me here at Brawley Manor.
You're welcome. Nice to see you.
So tell me, first of all, we're going to go through your career, not exhaustively, but with a reasonable amount of detail. But first of all, how would you describe it in 30 seconds or so if you were asked to?
Very long. It's a very technical journey and an enormous amount of learning that went in behind it right up till today.
Well, it's good to keep learning, and if you have a career that allows you to do that, then that's sort of a pleasure.
And there's 55 years in that learning period.
Dang. Well, let's get started with, I guess, the beginnings or precursor to those 55 years. Tell me about your early interest in electronics. Were you a guy that pulled apart transistor radios like so many other people who get into the field?
Well, when I started, there wasn't transistors.
Pardon me.
But my interest was very much in electronics, even at school. And when I had my first radio, which is a 3-valve radio at the time, a little portable, operating a huge 6-volt battery, I looked inside it and said, one day there's going to be a chip that'll do all that, and I want to be part of it. And lo and behold, my dream came true. I was and did. So that's really where it started. But I've always been interested in electronics.
Nice. And so what did you study?
First off, when I left school, I didn't have any family support, so I wanted to go to university at the time, so I couldn't. So I started an apprenticeship in radio and TV and did a 4-year apprenticeship there at Ward's TV Services. That was good. And I did several tech courses and did the first colour TV course at the time. And I actually came first in the state in that, although I was colourblind, which is a long story, but anyhow, it allowed colourblind students to start now.
Detail that if we go into every interesting detail, we might not get to the end. So.
Exactly, that's right. So from there, my school buddy, Chris Meyer, he started at AWA, and he gave me a call one day and said, "Would you like to come over and work for us?" And I said, "Well, yes, sounds interesting." It's because of being with microelectronics. And it was started in 1963, and I joined in 1967. So they were just putting this facility together and wanted somebody to look after the equipment. But it wasn't just that. It was a hands-on job for everything that was there, and it was again, a learning exercise right from sweeping the floor to helping design product. So from there, the facility grew, and it started off being called Advanced Devices Development Lab, ADDL. And at the same time, AWA had a physics laboratory right next door to it. And this was located at 348 Victoria Road, Rydalmere, which is at the back of the AWV factory. Yep. And the AWV factory was creating picture tubes, valves, some consumer electronics as well. And that's really how this facility started, because AWE wanted to make transistors. And for the sake of time, I won't go back why all that happened, but so they started up a little transistor laboratory right beside the so-called integrated circuit manufacturing facility down in the basement. And it really started with just 3 people. It was Doug Sutherland, which was the AWV factory manager, David Money, who was the principal engineer, brilliant guy, and Chris Meyer, again, a friend and very, very knowledgeable chap in electronics. And that's where it really started. So it just progressed from there through many years of development, right up until the facility got so large, it couldn't fit any more equipment in, and the technology was advancing to a stage where the facility just couldn't support it anymore. You couldn't get the clean rooms clean enough, couldn't get new equipment in there, on it goes. So, and it also became the most profitable division of AWA. And at that stage it was called AWA Microelectronics. Mm-hmm. So in 1986, there was a chap employed by the name of Dr. Bob McCluskey, who was hired to look into how do we build a new facility. And he located this development at, which is now the Sydney Olympic Park, but which then was Homebush Bay. And it was a development by Lease to create a high technology park. And that was wonderful, right? Because that was when the technology companies started to come in, like Akai, Sanyo, Alpha Laval, and several others around there, including us. So Philips just finished their facility in this huge, which it was the old abattoirs at the time, and that had been closed up. So it was a greenfield site, and then we started building in 1987, and it was completed in 1988, and in March 1988 it was opened by Prime Minister then, Bob Hawke. So it then went from, there's a huge technology jump, and we started when AWA Microelectronics started with 1.25 inch wafers with 20 micron geometries. It finished, before we moved, with 3 inch wafers with 5 micron geometries. We then, at Homebush, went to 6 inch wafers at 1.25 micron technologies, 1.2 micron technologies, which is a many, many nodes jump in technology. That was a huge effort on everybody's part, engineering part. We had some brilliant engineers, actually. And if I do say so myself, we've probably got some of the finest engineers in the world, let alone Australia, as far as, technologists go. So we got that facility up and running in 18 months, which was remarkable under any circumstances because we had to buy all this new equipment. There was only a handful of us that could actually run it. We had to do all our own engineering work with the help of some local contractors, of course. And we had to set up our own maintenance team because we're on our own. There's nobody here to support us. So anyhow, we got it up and running, and as the years went on, AWA was starting to implode, right? It was the outbreak of peace, and their defence division at North Ryde was consuming a lot of money. So they started... AWA. Yes, AWADI, yeah, that's right, Defence Industries, consuming a lot of money, and instead of, backing back on that, they were selling off a lot of their profitable divisions, like at Leichhardt and Ashfield and that, to keep financing it. But eventually it came to us in 1996, I think it was. That was when a US company came in called Quality Semiconductor. There's a number of things happened around that, but we'll just focus on that one. And AWA just really wanted an equity partner, but they came in and said they couldn't believe what they saw. They wanted to buy the lot, so they took the lot. And we became a Quality Semiconductor Australia at that time. They said it was very unusual to have the amount of skills and the breadth of technology and manufacturing in one facility. It's generally not known. So they were very happy with that, and we were making enormous amounts of silicon wafers going over to the US to Quality Semiconductor. But
you were making a lot of fairly high-profile Australian stuff, but you were an export business as well at the time.
That's right. A lot of our work was done for the STO and, of course, the universities that were the other ones, which had started at Rydalmere. We designed and built the cochlear implant, or at least the chips for the cochlear implant. Even if you look up the cochlear site now, there's no mention of AWA in there, yet we made that for 25 years. And it was between the Nucleus Group, Cochlear, and ourselves, AWA Microelectronics, that actually brought that whole thing to life. A remarkable effort, there's no question about that, and that's why Cochlear is so successful today. We also did some other medical electronics. Pacemakers for teletronics. We designed the first and made the first integrated circuit that went into a pacemaker. And when I look back on it, we were leading the world in many, many aspects, including manufacturing at the time, even ahead of Taiwan. The only difference is that overseas, the government put lots of money in to build the technology and the companies up, like in Singapore and Taiwan. Here, no help at all, except for one grant, which they called a START grant, which did help, I must admit. God bless them. But that was all. I mean, we could have been another Singapore here in Australia. And it could have been done easily if there'd been an injection of enough capital going into it. But so the medical electronics also went to Homebush Bay. And unfortunately, when Quality Semiconductor came into it, their CEO at the time, who now owned the facility, said that they had some bad experiences in medical electronics overseas in America themselves. And we had to get out of medical electronics. That hurt everybody around. And, we were so proud of what we did. And yet here it is, a company comes in and decides to restructure things, But they didn't last long, probably 2 years, and then
IDT?
They merged with IDT because the technology companies in the US started going south, and so they decided to merge with IDT. And IDT was always on the heels of Quality Semiconductors, more for their product portfolio rather than what may seem as manufacturing capability, but manufacturing capability had nothing to do with it. It was just a portfolio of products. Anyhow, IDT came in, and that was when I knew we were in trouble. And unfortunately, the American culture is always invest in their own facilities in the US, right? Not so much overseas, although they probably regret investing in China, but another story. Yeah. We then started making products for IDT. That was really good. It brought us into the real world, into the real world market of how aggressive it is and how savage it can be when you're dealing with other companies that was not only just dollar driven but cent driven. And unlike Quality Semiconductor, who wanted the facility because they were on allocation, when chips started getting tough to get, you get put on allocation. So if you want to get your chips made, you had to wait. And if your volume was small, you wouldn't get it made at all. It's probably like it is today. But with IDT, they had 3 fabs of their own. They had one in Salinas, one in San Jose, and one in Oregon. Their most advanced one was in Oregon. And as I say, that's when I knew we were in trouble, because the culture is don't invest in Australia. And in fact, once they discovered that they actually had a small fab in Australia, they think, well, what in the hell do we do with it? We've got 3 fabs of our own.
And meanwhile, they were shutting down some of their US fabs.
Well, they did. And I think it was because of us. The reason being is that the products we had were very advanced, and the design team was an excellent design team that we had here as well. And not only that, I said to their manufacturing manager, I said, I can make my wafers and chips far cheaper than you can. And he said, well, what do you mean? I said, I can prove it. I'll give you a quote. And I said, if I can't do it, I'll give it to you for free. Right? And lo and behold, it was a lot cheaper than what they could produce themselves. And this is why I think Salinas and San Jose got closed up, and they kept their Oregon fab because that's where all their investment was going. So things started to go south again in around the year 2000. And of course, the technology community in the US, in at least Silicon Valley, is pretty small. So everybody knows everybody else. And this is where Peregrine Semiconductor came in. And Peregrine, although we didn't know it at the time, Peregrine was a small startup, started in 1990 in the Naval Defence Laboratories in San Diego to develop radiation-hardened product on silicon-on-sapphire. And they'd been working on this for about 10 years and trying to work with some Japanese fabs. And really unsuccessful trying to get it commercialised. They had a lot of issues trying to get it going. So their CEO was met up with the manufacturing guy and says, they're talking to each other, one saying, how difficult it is to get their technology going, and the other one says, well, here we are, we've got a fab, and our new development is going into their latest fab in Oregon. So Peregrine says, well, I want a fab, and IDT says, well, you can buy this one. So that was when we became Peregrine Semiconductor. So
the Peregrine years of 00 to 08, I think. Can you tell me a little bit about the 90s? It was sort of leading up to the dot-com crash. There was a possibility of Intel opening up a factory in Australia. Technology was probably just starting to get interesting. The internet was finally commercially useful and people were setting up stores. Tell me what the mood was like and what you guys saw on the ground.
Well, it depends on many hours you've got, but, in the 90s, this is when obviously we were doing quite well on developing products. We developed 460 different products on 45 different processes. And I think the government, although we tried to get our Telstra's work, that would have been good, they just weren't interested in dealing with an Australian company. They were more thought that overseas could do it better. Never got Telstra, but the things that we did do apart from the medical electronics, we did the email metering chip for power meters. We did the Sonobuoys project for defence. That was another big project.
The sub-detectors?
The submarine detectors, that's right, yeah. They dropped from the Orion aircraft, hydrophones basically. And we did fire detectors for worm mould and a myriad of other things. I mean, as I say, for sake of time, we won't go through each one of them. But then the government, Victorian government in particular, with John Brumby, I had a conversation with him once, and he said he'd like to set up a facility in Victoria. And he said, can you move this facility down Victoria? And I said, John, in a word, no. He said, well, I can give you $35 million to do it. And I said, unfortunately, $35 million won't do it, right? That's when Ian McFarlane was also supporting us, and John and Ian apparently had a talk, and Ian McFarlane said he'll match it, give it up to $70 million. And I said, it's not going to do it, right? I said, again, you can't move a fab. You have to build and start again. And $70 million's not going to do it. So I said, the best I can do is put a fence around the facility and call it Victoria. That's a bit of a tongue-in-cheek thing. But so from there, I think Panasonic was one company that had a look and decided not to do it. But then the Victorian government and New South Wales government invited Intel out. And a group of 5 people came out, and I met with them. But they had a look around, and the government people with them, shoving them around, and they were probably there for probably a week, I guess, or not at our facility, but looking around. But one day they came in, and it was in the boardroom. The group then said to me, well, the head of the group, I've just forgotten his name now, but said to the government people, can you step out for a while? I want to have a chat with Andy. And we did. And they started asking some very relevant questions about, why are we here? Did you get government support? I said, apart from the Stark grant, no. But as much as we tried with all the ministers, with Barry Jones, and Barry Jones was very frustrating, honestly. But yeah, that's another story. And they said, oh, do you have unions? And I said, yes. In reality, they don't. He said, number one, that's a showstopper for us for a start. Anyhow, they went back, and of course it didn't happen. The government didn't realise at the time, but Intel don't offer foundry services. They make their own product. They need their own engineers, right, or a source of engineers. And that was one of the other things they were asking about. What's the supply of engineering talent? I said, in microelectronics, and I said, we've probably got them all. But the universities do it. And of course, TAFE and the universities are willing to offer the courses to build up if they've got somewhere to go. They've got to have a manufacturing site. You can't just have one manufacturing site and that's it. That was us, right? That whole thing went nowhere. So in reality, nobody from overseas is willing to set up here in Australia. And I suspect that the offering of the government to subsidise Intel, which is why they ended up in Costa Rica, because they got a big subsidy from the government there. The government probably couldn't afford it for a start, because they would have had to give them free land and money and all that sort of stuff, and it just doesn't happen. It doesn't happen in Australia.
You could say there are reasons it doesn't happen and maybe we need to do more, but you could also say, well, a company with all the money and resources of Intel asking for a handout is kind of at the same time a bit insulting.
It is, but that's the nature of those people. They're business people, and it's well known. Wherever they set up, the government has to ante up and put in, otherwise it doesn't happen. The only thing that would have been advantageous to us is that, personally, I would have liked to seen it, right? I mean, I always put a positive aspect to them, although I had to answer their questions honestly, that if you had another big industry here, you'll very likely find somebody else will do it. Maybe a Panasonic or an AMD or some other one might also set up here, because then they're starting to create the infrastructure around. That would have been the advantage, but it would have taken a lot of years to be able to do that.
I'd like to get on to the next chapter, which is
Sure.
post-Peregrine, the Silanna era, beginning in 2008 as Saphicon.
Just to conclude up to 2008, we made Peregrine quite successful with the silicon-on-sapphire. We commercialised it.
I mean, I've just missed a big chapter and gone off on a digression with Intel and some other unnecessary things, and we've missed all the great work on SOS and the mobile phone industry contribution, the Mars Rover, and a lot else. So my apologies.
When Peregrine came in, our fab was full of 6-inch wafers, of silicon wafers that went to IDT. And although I'd like to go back even further on that, explain several things, but we won't have time to do that. But it was just prior to Quality Semiconductor taking over, when we had to get into the foundry market to the US. And this was a directive from AWA to say, go and get some overseas work. So Andrew Greatbatch, who you saw in that little video, made a contact with a company called Crontel. And they made VGA chips for computers, and it was pretty leading edge stuff at the time. So David Sue, who was still their CEO, said that was when we were working only 5 days a week, 8 hours a day, right? That was the normal working day for the fab. And then David came in to me and said, look, we've got this opportunity to get this huge market for VGA chips. And he says, you can't produce enough with what you're doing now. So I said, well, David, we'd have to work 24 hours a day, 7 days a week. And he says, well, can you do it? And I said, you give us the work, I'll do it. And we did. That was a tough exercise. We only had the same amount of people, had to do each work 12 hours a day, and we were doing 6 days a week each until we could build up the employment with extra engineers and operators. And that was tough. And I said, just to show that I'm serious about it, I'll take the worst shift, which was midnight to midday. And it was a tough exercise. And of course, the unions weren't impressed with doing that. But anyhow, we did it. And I think that's what gives us the value to address overseas markets. And that was when Quality Semiconductor came in and ADT. That VGA chip, just a side thing. We bought one of these cloney IBM computers, and I opened it up, and lo and behold, it had one of our VGA chips in it. And I looked at the batch number that was on it, and that particular device, it took 3 months from when we supplied it to Crontel, they supplied it to the assemblers, went to the computer manufacturer, went to the open market, went to the resellers, came back from overseas, from a reseller here to us, took 3 months.
Yeah, wow.
That's how fast technology moves. Unbelievable. I couldn't believe that whole cycle only took 3 months.
Right. You were making pretty decent quantities of wafers.
Oh, we were full 2,000 wafers a month. We were chock-a-block full at that stage. So we'll get back onto Peregrine. When Peregrine took over, we went from all these thousands of wafers a month with IDT to almost nothing, because we had to get the silicon-on-sapphire up and running, which we did. We did that within 4 months, believe it or not. And the Japanese were working on it for years. That's how good our engineers are. They're really, really brilliant guys. So we got it up and running, and then they started working with defence, because that's where it came out of the Naval Defence Laboratories there anyhow. So they started getting contracts. High added value devices, but very small production for a wafer fab. You know, we're used to making thousands of wafers a month, and that gets reduced to maybe 10 to 100 wafers a month. It's pretty small, and we've got a fairly large facility at that stage. So as it went on, they thought, well, it's probably time they went public, right? Go for an IPO. And they had the Deutsche Bank at the time, and the Deutsche Bank says, nah, not good time to go public. And the reason being is that if you've got a wafer fab, that's a black hole for money. And banks and technologists do not like to have a manufacturing plant like that, which consumes enormous amounts of money, and it does. So they said, you know, you've either got to unload that or get into the volume market. So they got into the mobile phone market, making RF switches, and they did the first one with Sony Ericsson and Murata. Murata was that, but mobile phone manufacturers, they don't manufacture everything. They're more assemblers than that. So they assemble modules. So you've got your microphones, you've got your cameras, that's another module. You get the RF sections, another module. And Murata were making a lot of that in Japan. And so they managed to, with a very short story, managed to get that contract. The long story is it takes hours, but so they managed to get that. And this silicon-on-sapphire technology was brilliant. Absolutely brilliant for an RF switch. And an RF switch is that handles the signal coming in and out of the phone, right? And it has to be ultra linear, otherwise you get all these sidebands created and causes interference everywhere. And the silicon-on-sapphire technology was able to do that, produce these ultra linear transistors. So we were making millions of these things a month. And it just got so large for us that the technology got transferred over into Oki in Japan. And they started producing bigger volumes there because we couldn't get any more investment here to grow the fab. Although it was put to the government that, look, we're growing at a great rate of knots, we need lots of money. Yeah, good luck with that, yeah. So anyhow, it went on. And then, of course, they cracked their market. They had the volume production overseas. So we started to become more irrelevant at that stage, although we had a great design team. So at that stage, the Deutsche Bank says, well, you don't need a fab anymore, right? Unload it. And that's when it came to 2008. And the CEO at that time said, Andy, we're gonna have to close you up. And I said, Jim, don't do that. Just give it to me. I'll find a home for it, right? I tried with the ANU for a start. They were interested right up to the point I spent $100,000 with lawyers, doing all the due diligence and everything else. And at last minute, ready to put the signature on the line, they changed their mind. But apart from that, again, I'll keep the story very short. Another interested party came in only for the fact of wanting to make product, right? And this happened to be who was our now chief scientist and now the owner, which is Rob Lovin, came in and said, we want to make this particular device, memory device. And I said, Rob, well, yes and no. I said, if we're still here, yes, I'll do it for you. I said, but if we're not here, I can't do it for you because it's going to be sold off or to someone. Then of course he said, well, what do you have to do? Anyhow, I said, I've done all the due diligence. Within 5 minutes, I can give you everything, right? And he said, okay, I'll take it. Right. And that's when we became Silanna Semiconductor. So at that stage, then, that was in 2008. And of course, making product, we had some existing customers there, but then we said, well, we need to develop this technology further, which is for deep UV LEDs. So he put another $30 million and we built Fab 3, which is on the side of the existing building, and we put in an MBE, Class 1 clean rooms, finest stuff in the world, it really is. $30 million. That was $30 million. So that was in that Class 1 Fab. That was in 2010. It was with the MBE, working with gallium nitride. So that development just continued on over the years. We had some other foundry customers right up until 2019.
Before we return to that, I think we've missed a couple of things I'd like to cover from the 00 to 08 era. I'd like to know how you found it. You spent a couple of years leading the company, did you not?
Oh, yeah, I did, yeah.
What are your reflections on that? I'd love to hear them.
I've had all sorts of roles in the company over the years, and I think when Peregrine took over, I was their CFO at the time, and I remained at the CFO for a number of years, and then I'd have to look back over it again, but I became a general manager I think between 2002 and 2005. I wouldn't take these dates as being accurate until I look them up again. My memory fades at my age. It's like I don't even remember back.
If anyone's curious, they do best to check your LinkedIn profile or an old bio of yours.
Yeah, I mean, I've got it there if I could look up on the computer. But then one of the Peregrine guys came in, Chandra, and he took over the general manager role for 3 years, up until when it was sold to Silanna. And then when Silanna came in, I was the managing director of at that stage for a number of years, and I ended up I resigned from the board after a couple of years, and then was the general manager for a while. And then the final role was the VP of manufacturing. Yep. So roles have changed depending on, the situation at the time and who owned it at the time.
Yeah, right. Not speaking for you, but based on our conversation earlier and our conversation now, it seems like perhaps you're happiest in the factory floor.
It was, yeah. When I led the process engineering team, that was probably the time that I probably enjoyed it the most from a technology point of view, because I had daily contact with the engineers, and in fact, one of the engineers, Zachary, he left the company and went to the US, started up a startup there called Monolithic Power Systems. That, together with a friend of his, Michael, and that turns over $600 million US a year. Brilliant guys. And he started off in my engineering team here in Australia. That's what I was saying, we've got some damn good engineers. Where were we going with that?
Where were we going? I was asking about the Peregrine era. It was before you were, when we'll come to it later, before you were getting to the Metro. We were talking about you leading the company, where you were happiest within the company, and I think we've neglected to cover off on the Mars Rover. Not defining, but it's a highlight.
It's a highlight, yeah. And just one of the other roles was dealing with companies and networking. I enjoyed that as well. When people start to acknowledge that, you do have something rather unique and want to work with you, that's a good feeling. It's a good feeling to be wanted. So that was another kind of highlight. During that Peregrine time, dealing with their defence primes like JPL, Lockheed Martin, Northrop Grumman, there's the whole gambit. There's a list of them on your on that PowerPoint slide. We made they were designed by as a joint venture between Peregrine and the company itself, the JPL, for instance. Of course, you have to work hand in hand always with the customer, otherwise you never end up producing the thing that they want. And a lot of this was also done in universities as well. So a lot of the universities in the US as projects, and we were doing these multi-chip projects as part of it as well. So, and multi-chip projects is that you could produce devices cheaply for a university, but the designs were very good. I enjoyed working with Yale University. Eugenie was a great guy, and there were some very interesting devices that he produced. And he said we were welcome to commercialise anything that they made. And it worked for him because he liked to see his product actually get to the market, and we were happy because there were some good guys behind it as well in the design. Yes, it was the Mars Rovers. Another clever one that we did was with the University of New South Wales with the quantum computing project. Bob Clark was running it at that stage, and Bob came to me at that stage and said, we've got this qubit transistor in a dilution fridge that operates at 30 millikelvin, which is, a third of a degree off absolute zero. We want a voltage pulse generator to pulse this qubit transistor. He said, but it has to work at 30 millikelvin. And he said, will it work? And I said, Bob, I haven't got a clue. I have no idea. So I went around to Peregrine and many engineering people said, have you ever worked with cryogenics? And even the CEO of Peregrine, Jim Cable, he worked with cryogenics. He said, not very likely not going to work. And he said, you could almost guarantee it's not going to work. And I said, well, Jim, why not? He says, well, dopants kind of freeze out and on it goes. And I said, well. So I went back to Bob and said, look, I haven't got a positive response to say why it won't work. So let's try it. So one of his PhD students designed the chip, and I made it, put it in, and it worked. And he says, that's probably the only technology that would ever work at that temperature, and it was a success. I mean, only made a handful of devices. And a similar sort of thing for the SKA project, the low noise amplifier. These low noise amplifiers in these big antennas were huge things. And if you're going to make millions of these things, you're not going to make millions of these huge things. So they said the only way really going forward is to make it in chip form, but it has to be very low noise amplifier. And it was also sort of like a combined phased array as well. So we actually did that. We made that. But again, that project never went in the direction that it was intended to in the first place. It was an interesting exercise, but we made nothing out of it.
Right, and before we come to the Metro era, I wanted to ask that the University of Adelaide Picofab facility, and you mentioned Bob Clark, and I read a recent report that he did for ASPE and had a chat with him the other day, and one of the things in the report that is cited quite favourably in things we can do in Australia and where universities and private companies can work together to a good end was the University of Adelaide facility. Could you tell me about that? It might be outside of your brief, fine if it is, but if not, can you say a little bit about that part?
That facility started up because of Peter Atanakovic, who's probably one of the most brilliant guys I've ever come across. He's just so fascinating. I mean, he'd walk into your office and he'd fill your whiteboard up and you'd sit there for hours watching him. With some personal circumstances that he could only stay in Adelaide. So they were getting a lot of family support down there. So he would have liked to have stayed in Sydney. In fact, he'd also like to have been in Brisbane as well now. But so he had to work remotely to support Sydney as well. He knows everybody down there. I mean, he's a very famous scientist down there. Anyhow, the University of Adelaide turned around and said, well, we can give you some space down here, almost free of charge, if you want to do your research work down here with MBE. And their interest is, of course, they want to teach students about the latest technologies, gallium nitride, and which now is going into gallium oxide. But so it was very much in the university's interest to get him in there, right? I think he's an associate professor there as well. But anyhow, so Silanna got an MBE for him and put it in there. And as time went on, he had other support equipment around it there, and he got a little bit of a grant from South Australian government as well. Wasn't a lot, but it still helped. The amount of patents that he's raising now with this new technology, I think he leads the world in it now, in this gallium oxide technology. I'm 100% he leads the world in it now. Be on the path to commercialising. Now, if we hadn't had this massive setback from Sydney Metro, we probably would have been able to get it commercialised even now, right? Because the facility would have already been there to help it. But now it's in Brisbane. Brisbane is, the clean rooms are in place and they've got a new MBE there, and the old MBE had gone up there. Now they're having to rework that to get it up and running. But so I think within the next couple of years, some of that's going to be truly commercialised and will be leading edge stuff in the world now. That's how it started. Together with him, together now with Brisbane, I think we're going to start to see some really nice things come out of Australia as far as technology goes, and particularly in power devices. Still working on deep UV LEDs. It's gone from 265 nanometer, which is the standard sterilisation level, but not very kind to humans when you get exposed to it. So when you're operating around 210 nanometers, you don't get affected, but it still has a sterilising property. Right. But that's a tough one to crack as well. So that's what's happening now. But power devices are still the way to go. Power amplifiers, very much the sort of thing that you need for radar systems and defence and so on and so forth. So although it's set us back a few years, it'll pick up again. And hopefully this time the government might see enough sense to be able to support it as well. Because, an MBE, you're talking about $10 million just for one machine. And to be able to create the volume out of that, you could need multiple machines. And that just doesn't come out of your pocket very easily, $10
million is bigger than the biggest grant I can think of, unless we're talking about those collaboration stream grants that the government was throwing around like confetti before the election.
And the governments turn around and say, yeah, we want that facility up there. We'll give you an incentive. The incentive's between $1 to $2 million. Well, I mean, that doesn't even cover the freight charges to get anything moving.
Yeah.
So, and this is kind of why, when you see at the end of one of those presentations what I learned over the years.
Things you've learnt over a half century, but before that, really got to come to the Metro decision. When did you find out about the compulsory acquisition by New South Wales government, and what were you doing at the time?
It was in October. Well, I was upstairs working on my computer. The receptionist came up and said, there's some people here want to see the CEO. Well, I wasn't the CEO at the time. It was Rob in Brisbane, but so it was the next best thing. And this was in October 2019. There was two people at the door. And they said, can we talk to you? I said, well, okay, what about? And they said, well, we're doing a compulsory acquisition of the site. I said, what? Is this some sort of April Fool's joke, is it? And they said, no, it's serious. They explained what was going on, and that we have until the end of June the following year to get out, which is basically 18 months.
This was in the, you would have been in the thick of COVID as well as decommissioning.
Yeah, it was a tough exercise, yeah. So then, of course, I got immediately onto the owner at the time, and then he called the lawyers, and it just went from there.
What representations were you able to make? Who did you speak to after you got this news, and what did you do what can you do, if anything, to say, guys, you're insane?
Well, that's when, as I say, the lawyers were immediately alerted, right, because they have no understanding of what that meant. You know, we were still supplying all the high-quality product back to the US defence primes. We had a local company, Finisar, who were producing gratings, optical gratings for their market. We were working with a company called Lapis. Their production depended a lot on what we were doing. And these characters come in and turn around and say, well, we're going to close you up. Oh, yeah, thanks very much. We don't want that to happen. And not only that, once you've shut your production, that's silicon-on-sapphire technology is gone forever for us. We know all about it, but can't produce it.
You built it from scratch. You've got so much IP around it and so much probably knowledge of very finicky, very expensive machines and so much else attached to it, not to mention, horizons for planning by all your customers, and you say that to the government and they just kind of go, what does that even mean?
They have no idea. Even their so-called experts, they're brought out from the US to say, yeah, you can move this. They have no idea. Honestly, I fail to see how they can even call themselves experts, but even have the right to talk about it, let alone try and tell you what to do about it. We have 50 years of knowledge on this, of how to build and maintain and operate fabs, and all the complexities behind it. And I tell you, it's extremely complex. It's one of the most complex technologies in the world, right? Without a doubt. And we knew all about it, and we knew how to do it, and this is why we became so valuable to overseas companies. They came in and said, well, that was it. We didn't have much choice on that one, so then we had to start planning immediately of how to survive. I think that was what it was. It's a survival strategy more than anything else, and how to make our customers survive. Because whether you have a legal responsibility, you have a moral responsibility to your customer, Otherwise you don't have a business. If you can't maintain a good relationship, and I tell you, it's hard to maintain a good relationship when you tell your customer, sorry, we can't make it anymore for you. And it's not a good thing. That was probably the worst period I've ever gone through.
Could you comment on the cruel irony of the New South Wales government making a report on growing the semiconductor in New South Wales, roughly at the time they're shutting it down? I would laugh, but it's just bizarre.
That's a joke, isn't it? And that's obviously one group in the government that doesn't talk to the other group. So here they are. They say how important the semiconductor industry now. I could show you on the computer from overseas. They say it's not oil, it's not lithium, it's not materials. It's the semiconductor industry that's the most important industry in the world now. Everything has a semiconductor in it. The car industry is in a lot of pain because they can't get enough. It just goes on and on. That's the most important industry. And I think the government here in certain circles have turned around and said, yeah, we should have a semiconductor industry here. And what do? Go and destroy the only one that was here. Yeah, destroy it. And I think, how stupid is that? Don't they ever think about sharing plans amongst these government departments and saying, well, we're going to put a tunnel from the city to Westmead and train stations are going to pop everywhere. Can't you pop up a train station a little bit down the track a bit so that it still leaves us alone? And you think, and these things take years and years of planning, not 18 months, right? Not knocking on your door and say 18 months and you've got to get out. It
is bizarre.
It's bizarre, but as you've seen on my presentation, we never give up, and we're never going to give up. Although I'm not part of it now, as you realise. But I still feel I'm part of it.
You've spent your life there.
It's a life commitment for me.
I wanted to ask you, I've only seen one article about the subject, and it was in the Australian, and it was behind a paywall, so I couldn't read it. I think it was by Robert Gottliebsen, and that's the only mention I've heard of the blunder the New South Wales government has made in shutting you guys down.
I probably didn't read it either, but that what I've just described is the reality behind it. So he probably got the information from us anyhow, But it is definitely a blunder. There's no question about that. They could have planned their way around that. I'm almost certain of that. Even going back to Sydney Metro, saying, well, why can't you just route it around? Even the place next door is a warehouse, right? It's not a manufacturing facility that can't be moved. Even that, and they said, if it had been sort of years ago, they might have been able to do it, right? They didn't say no, they couldn't do it. But now they say they can't do it because everything's done. I don't know how many other properties. I think it was something like 90 other properties that were affected while they were doing this tunnel and where the train stations are going and that. But it's an unfortunate set of events, and we were one of the casualties of it.
I've chewed up a lot of your time, so I've only got a couple more questions.
Yeah, go for it, yeah.
I wanted to ask about your opinion of, as you just said, the semiconductor industry, probably the most important in the world, and governments are really treating it like that at the moment. There are a lot of countries that are spending a lot of money because they realise the strategic importance of having
Absolutely,
that.
Yeah.
I mean, it might be too much to ask you to comment on geopolitics because it's not your brief, but if you want to say anything about the state of the world and about the semiconductor industry's role in that, you're welcome to.
Again, semiconductors are the most important thing. You wouldn't, without it, you wouldn't have the internet. You can imagine that if you didn't have the internet, the world would stop now. Everything is electronic, literally everything. People live by their phones, right? What would you do without your phone now? Your whole life is on there. Your bank, everything is on your phone. But anyhow, apart from that, strategically, there are a few countries in the world that excel in semiconductors, the US being one, certainly parts of Europe also. Taiwan, South Korea and Singapore, and China. Now, China is our biggest worry. It has been for the US for some years. The US sold their souls to China many years ago by allowing them to develop the technologies there. all trying to save money, and it's cost them in the long run. But so they're trying to get it all back again. But the big issue is that China and Taiwan produce the bulk of semiconductors in the world now, percentage-wise. Now, if China take over Taiwan, they will hold the world to ransom, without a doubt. And I think that's our biggest worry. And I think this is why countries are now want sovereignty, right? The US wants to be kind of independent of that. But personally, I think it's too late. And I think whatever they do, whatever the world does, never allow China to take over Taiwan. Because if they get their hands on that semiconductor industry, I think the world's going to be in trouble.
Go to some of the things you've learned. I'm going to let you volunteer a couple of points from that list.
Well, the first one, I always had that factor of pi. And every time I quote that, everybody laughs at me, you know. I even get held down at some stages from the managing director and said, well, there's your best estimate. It's going to take you 2 years to get that going, and it's going to cost you, I don't know, $5 million. Well, apply my factor of pi. It's going to be 6 years, and it's going to be 3 times the cost, right? And I tell you what, I've gone back over history, and I've just about proved it every time. There's always factors that you can never realise when you're estimating something. A Sydney Metro. The various other things that we've done. Pandemic. Yeah, there's always something that slips in there that you can never have predicted, right? And although, and this is coming back to another one of these points, although a VC, you've got to put your so-called best estimate to a VC, and you're very unlikely to get funded anyhow because they want, a 3-year return, 3x the value, and an exit strategy. Even though you put the best on it, you run over your estimate, and your funding is going to get cut off anyhow, right? So that's always the tough side of it, Facing reality and facing, I won't say it's a dream, but people always try with their best estimate, right? That's what you're selling your soul on. But, when these other factors that come in, and they're always an excuse, right? Then you've got to turn around and say, what's the contingency plan? Where's your plan B, your plan C, How do you get out of it without running out of money? So money becomes the next most important thing there, right? Because these things are expensive. Get a certain amount of funding based on your first estimate. And if it's going to take 3 times longer, you're going to run out of money, right? without a doubt. You've got to have plans in place as you're building it to be able to sort of hedge your bets on this. How to get an income while you're trying to grow what you're starting to do originally. But that's diverting off that list of stuff, and I don't have my list of stuff in front of me. But
let's return to it. You made some comparisons between Australia and America, and I thought you were well placed to comment, given that you were, for a while, answering to American stakeholders. What can you say about differences across the cultures?
I think it's a level of risk. Australia is not willing to accept risk. They want to bet, that every horse is a winner. They just want to bet winners. Where the US, a very different strategy. They're quite happy to fund 10 projects and have 9 fail, and have 1 success. Where your Google comes from, where a lot of these things. They don't talk about and what that does do, and I'm talking about the US now, if they're willing to fund some of that, maybe even the high risk ones, the rewards can be great. I mean, on high risk projects, because nobody else will fund it, right? But what it does do, it allows more opportunities to start up. And in doing so, you're very likely to to have more results coming out of it, more technologies, more different products, whatever it is. It's a numbers game. The more you fund, the more likely you get out of it on a percentage-wise. But generally speaking, ones that do come good in a big way. Whereas in Australia, they're not willing to fund anything that's risky. You go to a VC, and of course, and I've mentioned, if you're an engineer, they don't want to talk to you in the first place because they know that you love technology and you can forget about the market, So they're very risk averse, and that to me is not a good thing. The US are willing to put in, they've got DARPA, for instance. That's a great program, but they're willing to give you $1 million to research an idea, just an idea. It doesn't even have to get to market. But that doesn't exist here, right? You've got to be able to show that you can actually get a return on it here already, even before you start. And again, that doesn't generate the seeds for growth. And a lot of the things that these research projects in universities, there's some great ideas in that, but trying to get those things funded is very difficult,
I agree with you. I think on the plus side, I've seen things improve an awful lot for Series A rounds and seed funding rounds.
Oh, it has
greatly improved.
Well, without a doubt, the last few years, yes, it has. Because they're realising now that you need technology. Otherwise, we're going to be a servant to the rest of the world. And I think the thing that has been good for us over the years is our natural resources, right? Our mining, our coal, our exports in that thing. It's made us relatively wealthy in global terms. But what it does do, it's pushed technology back, because that's always been the highest risk venture. Technology has always been high risk. Even when I had conversations with Barry Jones, and I mentioned him earlier, he says, I showed him through a facility. He said, "Oh yeah, it looks wonderful," And he says, "Oh, it's big investment. You need all your capital up front to even produce the first device, right?" Mm. And he says, "Why in the hell would I invest in technology like that?" And he says, "Particularly when I can put it in pharmaceuticals or mining, right? Pharmaceuticals grow. You put $1 in, you can make $1, and on it goes, and it just grows. So." That's where I would put my money. So I already know at that stage you've got a fat chance of semiconductors with Barry Jones. But
yeah, it's a fair point. I mean, if you're investing in anything and you have a certain amount of money and you want to see the best return for it, you're not going to go straight to the trickiest thing that probably has a pretty good chance of failing. It's just human nature.
But failure is a fact of life. It's a part of technology growth. You look at the industry itself. How many shots have you had at making a transistor? How many shots have you made at any technology? Failure is a normal part of life. If you haven't failed, you haven't tried hard enough. As I say, that's just a normal part of life. And so you can't rule that out to start off with, saying there's always a chance of failing.
Yep.
You've just got to have the wherewithal and learned enough from your failures to go to the next step, right? Yeah. And that's how the industry develops. It's
based on accepting risk.
It's accepting risk, but you've got to know then if there's a chance of failure, how do you survive it? Where's your plan B to say, well, if you've hit this roadblock, and the company's done that many times, right? Developing a process, developing something, and then finding out, hey, it just doesn't work. What do you do next? How do you get around that? What's the alternative, right?
When the law of pi plays out, where will you be?
Yeah, that's right. Broke. but so that's the difference between Australia and the US. Admittedly, now that the word semiconductors is starting to hit more of the headlines now, I think that's good. Even looking at you get a manufacturing number, right, as an industry classification, right?
ANSI code or something.
Yeah. You look up and try and find semiconductors there. Brothels actually get a number, an industry number, and semiconductors don't. So that's what they think of us. I had to laugh at the time when I was looking. Many years ago. Okay. Many years ago, because it was part of a grant I think I was applying for, and it asked for this particular industry code. And there's a whole bunch of published codes. And I was looking through it, and as I say, brothels came up there, and I was looking for semiconductors. And the only code that I could get was other manufacturing. That was the only one that would suit. It had woodworking, it had metalworking, it had all sorts of stuff. Yeah. Very much related to what Australia kind of does, but for technology, nah.
Maybe one or two more questions if you still have the time and willingness. One of the standard questions, it's sort of a stock question for this series. I ask pretty much every guest, why is it important that Australia have a strong manufacturing ecosystem? What's your view?
Well, it's technology. We can't live off our resources all the time. We have to have at least some advanced technology. We're a very small nation, and our labour is not that cheap, right? So we can't go into high volume, cheap manufacturing. We're not a China, we're not a Singapore, we're not a Taiwan or India. India's going to be the next, obviously, the next one. So we can't do that. So what we do have, we have good universities, we have a lot of smart people, but we don't have the manufacturing base to be able to take those people. I hired a lot of people, a lot of students from the universities over the years, and they turned out to be quite brilliant people. So that is what we need. When you look at Finland, for instance, a small country, similar sort of level of population, they started the mobile phone industry. Well, they don't have any natural resources, so technology was the obvious thing. But the thing that's put us back is because we did have natural resources that we could live off. So I think that we now need those high technology manufacturing organisations. And what that does, it supports a lot of the infrastructure around you. You'd be surprised how many people actually depended on us at the Olympic Park before we went. They supported us and we supported them, you know. All the high purity gases and chemicals that came into Australia were because of us, right? It took us years to be able to work with Lindy and Corgas to be able to set up bringing those pure gases in. The benefit is the universities can now tap into that, right? So it helps them to their research projects be able to get to those sorts of purities and that. Pump manufacturing, because everything equipment-wise is more vacuum pumps, or the cryo pumps or whatever. That industry started up around us as well. Yep. Creating clean rooms with Xanders, that was also. So if you had multiples of this, you know, and each of the states had that and all linked, what a great country we've got. And communication was, because we're such a huge country, area-wise, and a small population, you need communications, you need the technologies behind it. There's so much we could support if we had that manufacturing. We're isolated. A number of US manufacturers of equipment did some of the development work here. And the reason being is that it's an isolated country, so a lot of their IP that they're working on just didn't filter its way out of the country. Whereas if you're doing it in the US or other countries, you know, engineers basically spend 3 to 5 years in a company before they go to the next doorstep, you know. So a lot of that technology gets averaged amongst a lot of other companies, where in Australia they can develop here. And that's another big advantage that we have. The isolation is actually an advantage. And that report that Bob Clark did, and you mentioned that, that was really good. I read that. I think he really highlighted that partnering with other organisations. We definitely have to have a technology industry here. At the end of it, I think the thing that you didn't actually get to, and it's probably the hardest bit, is how to make it happen. He said you need to spend $1 billion, and that's true.
Yeah.
I mean, it's not straight away, but it's over a number of years. But who in the hell's going to champion it? The feds have got to be the one that's got to be part of that. It's not a state-driven one. It's got to be a federal one. Who's the champion of that? It's not Ian McFarlane anymore. It's not a Senator Button. It's not... Who in the hell is going to do that and then say, okay, we're willing to take the risk on growing an industry here, but we're going to spend $1 billion. Who in the hell's going to do it? That's the bit that's missing.
Yeah, and that again comes down to the fear of failure. There are going to be projects that fail. You just have to kind of say, well, that's part of the game.
It's part of the game, you know, that's right. Providing that the knowledge doesn't go out of Australia, there's enough knowledge to be able to build a semiconductor industry here, if it was needed. But it has to be very selective. I mean, it's just not creating another Intel, it's not creating commodity products. There are very specific technologies that have worldwide need. And EV is one, and creating power devices, we can make power devices.
Picking a niche but meaningful market was the focus of your old company. Where do you think that some of the hopes for Australian semiconductors lie?
I think certainly working with the so-called latest technologies, like compound semiconductors. Yep. I think the CMOS side of it now is done and dusted. That's like the car industry. That's going to be a China-driven thing, and it's a volume game, and it's not particularly high technology. It's just volume. That's all. It's like producing calculators. You can get them on the end of your pen now, but when it comes to sensors, when it comes to very specific, highly advanced power devices, power amplifiers, you know, a whole range of products on compound semiconductors, we've got a very, very good chance of doing it. Very good chance of doing it. But it needs the facilities to do it. As I say, Silanna's starting that up again up in Brisbane. But there's another 5 years in that yet, because it takes a lot of money, and money's not easy to get. Grants and that don't create technology. They shorten the time down. This is really what it is. It's all about managing time. And that's all money ever really does. It manages your time. You know what you want to do, right? Otherwise you wouldn't be starting in the first place. You want to be able to get there without running out of money, but you need a supply of money to make it happen faster. And usually a good investor comes in and says, how much do you need to shorten the time? I've had that question many a time. And it's very true. If you can afford a few more engineers on the particular project, or if another piece of equipment that shortens the time down. For some of the developments where I had to put in a packaging facility, right? We used to, when we were developing an integrated circuit, we'd package it, have to test it to see if it's functional right. Well, didn't have a packaging facility here, so we sent it to the US, Unisem for instance. Takes 6 weeks and $10,000 to get a handful of devices. Well, I can tell you, 6 weeks turnaround when you're developing something will kill you, because you have many iterations on these things to be able to. So I turned around and said, well, we need a packaging facility. So we put our own packaging facility. I've forgotten how much it costs now, up in Brisbane at 8 Mile Plains. We now could package devices in one day. You'd send the wafers up there overnight. We'd get packaged the next day and sent back on the plane that evening. All right, and it certainly wasn't $10,000, right? I mean, it was a plane fare, but of course you had to depreciate the facility. The best thing ever did, because you shortened your time down. Yep. You managed the time, and people don't realise that time is your most critical factor. And if you can get enough money in to manage your time, then you'll win. right? Because you will always have a plan B if it hits a roadblock and so on and so forth. But,
well, I think that's probably
that was my 2 cents worth.
No, 2 cents is why I'm in your house. Well, thanks very much for speaking to us on A Manufacturing Conversations, Andy. It was lovely to meet you.
My pleasure indeed.